Mana buat tadi ah? Oh, share screen. Okay. Alright, so last time, where did we stop? We stopped at thermal effect, is it? Kan?
Yes.
By the way, awak punya quiz tu bila deadline dah submit dah? Awak dah submit semua?
Dah.
Okay, good. So kita ada, so you should have one more quiz on optoelectronic. Nanti saya bagi lepas kelas, so deadline dia minggu depan kot. Okay, so that one will also be closed book. Saya tak buat lagi soalan final, to be honest. Okay, you know, mesti awak pun banyak assignment dan banyak quiz kena buat kan. Kita orang lecturer ni pun penat tau buat soalan. Nak kena buat soalan tu kena tanda pula tu. Aduh. So kalau saya mikir ni 5, 6 students okay lagi. Kalau yang subjek genie saya tu, innalillahi wa inna ilaihi raji'un, saya ada 40 lebih. Betul essay panjang-panjang rasa macam berpinang mata baca. Okay. So kalau tak buat kerja lain tak apa. Let's say if I'm a lecturer, I just teach. Macam cikgu lah. Dia tak buat benda lain. Cikgu pun soalan pun dia tak buat. Soalan final yang betul-betul dia tak buat. Dia macam dia ramai-ramai ataupun SPM, government bagi. Cikgu sebab tu beza cikgu dengan lecturer. Lecturer siap dengan course outline pun dia kena buat. Cikgu dia tak perlu buat course outline. Dia cuma ambil semua daripada Kementerian Pelajaran, dia execute. Tu cikgu. Lecturer daripada course outline, kepada textbook, kepada video, kepada A to Z dia kena buat. On top of that, kena buat kerja-kerja admin, kena buat research. So tu bezanya lecturer dengan cikgu. Tapi cikgu kata dia stress. Tapi lecturer jarang awak dengar lecturer stress. Awak dengar ke lecturer stress?
Kau minum.
Apa Salihin?
Medium
Busy
stress ke?
sangat. So nak cakap dia stress.
Apa tak dengar?
Medium stress ke?
Saya tak stres. Saya bahagia. Okay. So, tapi ramai lecturer... Apa tak dengar?
Sebabkan lecturer busy sangat, dia tak sempat nak cakap.
Bukan sebab tu. Saya rasa lecturer ni dia a different breed. If you kalau tengok lecturer ni dia orang macam mana? Dia orang higher educated. Dia education dia higher compared to orang lain. So bila awak tengok orang yang higher education yang higher ni, dia orang ni lebih composed. Dia orang ni macam biasanya orang yang cerdik pandai ni dia tak you know, just simply bercakap macam tu lah. Dia orang macam berfikir banyak sebelum bercakap. So jadi dia jarang dia jarang nak memalukan diri dia untuk like complain in social media ke apa nama tu. So jadi dia memang spesies macam tu. Spesies yang dia spesies baik lah, to be honest. Sebenarnya lecturer ni dia ada certain spesies. Kalau dia jenis yang macam hardcore, macam advocate, dia takkan jadi lecturer. Dia akan jadi politician ke, dia akan jadi lawyer ke. Dia memang sesuai dengan nature dia. Nature lecturer ni dia memang dia jenis nature baik yang submissive tu, yang kita terima je and then you know terima je buat. Dia jenis macam tu. So especially kalau engineering or science and technology, kita ni orang baik-baik, kita buat je kerja kita, you know, kita tak ada rasa nak memberontak ke. Dia memang spesies dia macam tu. Sebab tu dia boleh tahan lama, sebab dia memang style dia macam tu. Tapi kesiannya sebab bila dia orang tak bersuara, maka orang tak tahu dia punya plight. Saya yang jenis yang mungkin spesies lain sikit daripada lecturer. Dulu saya gitu juga, tapi sekarang ni macam saya lantak lah aku cakap, I don't care, you know. Orang nak marah saya pun, so what? Marah je lah. So orang nak mengata saya, mengata je lah. So tapi bila orang senyap, dia macam dia tak cerita benda yang dia go through, dia prone to burn out. Kalau tahu burn out, ramai profesor lecturer yang sakit jantung mati. Kalau tak tahulah, macam ramai. So ramai kena cancer. So benda-benda ni sebab dia stres. So sebab tu macam saya kesian lah orang yang senyap, sebab dia biasa dia baik sangat. Orang bagi dia terima, orang bagi kerja dia terima. Dia tak pernah say no. Dia memang sangat baik. Tapi kesian orang baik-baik ni, sebab ni dia tak erti nak menolak, and in the end dia sakit. So I learn to say no. How do I learn to say no? Saya dulu jenis tak sangat, saya ni adalah orang tiba-tiba duk cerita. Memang saya dulu seorang yang sangat submissive, maknanya sangat baik lah. Masa saya sekolah menengah ke sekolah rendah, sangat baik. Memang tak tahu, bukan saya nak puji diri saya. Saya tak pernah kata no. Saya akan ikut je apa, walaupun benda tu bodoh. You know, walaupun benda tu bodoh. So sebab kita orang Melayu memang macam tu biasanya. So jadi I change when being pressured. Orang Melayu ni, sebab tu aku juga kena pressure orang Melayu ni. Betul, bila kita kena pressure, kita akan berubah. So bila saya belajar dekat UK tu, masa undergrad pun saya tak kena pressure mana sangat, because I was still living 2 tahun saya duduk dengan mak ayah saya masa degree. Mak ayah saya masa ayah saya buat PhD masa tu. So setahun. So macam saya setahun duduk seorang, saya tak ada pressure mana sangat. Tapi bila buat PhD tu, supervisor saya suka pressure saya. Dia suka apa? Dia suka provoke. Dia provoke yang yang buat dia nak suruh kita mengamuk tu, macam tu. Kita ni jenis baik kan. Kalau orang provoke kita tak mengamuk, tapi dia nak push kita, suruh kita mengamuk, and so that kita boleh stand for our own right. So kadang-kadang, just to tell you the story stop recording ya. Dia kata person, insyaAllah. Okay, kita masuk balik lah. Habis dah berapa jam dah bercakap ni. Tak apa. Semikon ni bukan susah sangat pun. Okay, so next. Base resistance. Okay. Okay, hari tu kita, so the topic takut semua dah cuti lama, dah lupa semua benda. Sebenarnya mungkin saya yang lupa. So jadi we are talking about BJT now. Our topic is bipolar junction transistor. We looked at how it works, and we also looked at how it works in terms what are the modes that we can have. We can have forward active mode, saturation mode, cut off mode. Tapi we didn't discuss very detail on the saturation and cut off. But we focus more on the forward active mode, which is in the when it works as an amplifier. Okay, saturation normally used as a switch, and cut off also switch. So it's either on or off. Cut off means 0, saturation means 1. So you can use transistor as a switch. Okay, then we talk about how what happens how in regarding the carriers. What lagi? So we also have drawn the energy band diagram of the forward active mode of a BJT. You should be able to draw that. Both NPN and PNP you should know. And we talk about the IV characteristics, the common emitter characteristics. We have the IC versus VEC or VCE, and ideally it should be constant. Okay, and you know why is it constant. Hopefully you still remember lah why it shouldn't change. I don't want to ask you, just make sure you know. Then we talk about so here is how do you get the base current. We also talk about that. And then Then we talk about early effects. So next ialah important effects in BJT, or sometimes we call it the secondary effects. BJT. Secondary effects for BJT. Okay, so there are few secondary effects in BJT. Number one we talk about is the early effect. So what is early effect we talk about, and mostly has to do with the slope of this. Why is it increasing instead of being constant? Instead of being constant, it's increasing. Why? Okay. So, and then we talk about breakdown voltage. So this is the number 2 punya secondary effect, which is the breakdown voltage. What is the breakdown voltage in BJT, and how do you get it? Okay, and so we also discuss on that. Then the third effect that we talk about is the thermal effect. In BJT, is any semiconductor device, if exposed to variation in temperature, will have its performance affected. Any semiconductor device with the changes of temperature, a lot changes, especially drastic change in temperature, will have effect on the performance, and including BJT. So we talk about the thermal effect, and we talk about thermal runaway. What is it, right? Then now we want to talk about the fourth secondary effect, which is the base resistance. Okay. So for this, I need to open my book. Ingat lupa. Okay. Okay, I need to draw for this. So, how do you know that there is this base resistance effect? If you look here, okay, this is a graph of the IC, collector current versus VBE. Okay, so it's supposed to be a, what do you call it, like a diode, right? IC versus VBE is just a diode. Diode apa nama ni? Diode characteristic. If you look at the y-axis here, is it linear or log? Is it linear scale or log?
Log.
No.
So it's a log scale lah. So be careful when you read any graph. Kadang-kadang student dia main pakai hantam dia tengok. So you should, especially in semicon, there are many graphs that we plot it log. And then can you see here, is it linear or log, the x-axis?
Linear.
Linear. So most of the time we plot it log linear. Why? Because why we plot it in log? Because the current changes abruptly. There are a lot of the range of the smallest current to the biggest of the current is very big. So in order to show everything in one graph, we plot it in terms of log. Okay. Alright. So so how do you know we have the base resistance? Is here you can see. So a normal theoretically, okay, if you plot a log linear graph of a IV, current voltage characteristics of a diode, it should be straight line macam ni. This straight line here, it should be straight line. But when you do experiment for any diode or this BJT, you plot the IC versus VBE, you can see it's deviating. It is lower than what the slope should be. So this ideally it should be like that, tapi dia macam ni. Okay, so this is an indication of a base resistance effect. Okay, kalau dalam untuk Faiz kalau untuk diode biasa, kadang-kadang nama dia kita panggil series resist, apa nama, tak nak warna biru. Kita bagi nama dia series resistance effect. Okay, series resistance effect. So because it's BJT, we call it base resistance effect. So when you have this resistance effect in a diode, it will deviate from the ideal curve. Okay, and you know there's something this is not ideal, and it should so okay, then the next question is, if we have this base resistance effect, so what? Is it good or bad? If it's bad, why? Anybody?
Because we cannot predict
You cannot
the
predict.
curve. We cannot calculate.
Let's say the resistance is okay. Kalau if that's your argument, say let's say the base resistance is from the word resistance here. I mean there's a resistor, added resistor. Let's say the added resistor is constant. So every time you measure, you get this. So you can predict. Let's say. So what else? Okay, the answer is okay, heating. Okay, now let's, so yang ni, now I just show to you how the IV. Now let's look at the why the base resistance effect, why you have this base resistance effect in a diode, in a BJT. Okay. So base resistance effect. Okay, now. Okay, if you still remember a real BJT, how do we make it? Yang kuih lapis tu kan? If you still remember the kuih lapis. So you have the okay. So do you still remember which one is which? This is the collector, this is the base, this is the emitter. Okay, it depends on the doping. We want the highest doping is always at the top. Okay, this is how we make the BJT in real life. Okay, so if this is the BJT, right? So now what happens is, if we forward bias the base to emitter junction, so remember, see here, okay, kita draw. I'm trying to see my drawing. Okay, base emitter. Okay, so we have, ni sebenarnya diode kat sini kan, ni BE, ni Allah, apa macam ni, NPN. So this is N, this is P, this is N. Okay, so we have P and N, you have diodes. Okay, but this base terminal is over here. Okay, and then this emitter terminal is over here, collector terminal over here. So if we connect this, the base, to a positive like source, right? So because you want to forward bias the base to emitter junction, ni base, ni emitter, right? So you positive, negative, right? You want to forward bias the base to emitter junction. So we will connect the base to the positive and emitter to the negative or to ground. Okay, tidak membantu warna kuning. Okay, let's see guna warna lain. Oh, negative. Okay. So when this happens, right? Kalau you imagine, you need to imagine like current is like water. Current is like water. So you always go to the least resistance. Kalau ada river, kalau ada sungai, banyak-banyak sungai, sungai air nak mengalir kan. Tempat ni lebih macam besar jalannya, ni sempit sikit. So air kebanyakannya akan pergi lalu dekat tempat yang besar. You always the least resistance. Current macam tu juga. Dia akan lalu kat tempat yang tak ada, yang kurang resistant. So now okay. So okay, let me, how do I explain this? Okay. So current akan lalu daripada sini. Dia akan masuk sini, pergi sini. Okay. Warna hijau lah. Jauh ni. So dia akan pergi macam ni. Okay. So bila current terlalu macam tu, you need to imagine yang ni, this part, this green area is actually a base. A base area highly doped or low doped? Base you
Low.
high dope,
Low.
Why is it low dope?
Want to decrease the recombination.
Yes, good. So to reduce the recombination, you lowly doped. So when you less doping, how about the resistance? Is it higher or lower?
Lower.
Okay, Azam jawab lower, orang lain?
Mesti jadi higher.
Faiz jawab higher, orang lain? Aiman?
Higher.
Okay, Aiman kata higher. Solihin?
Higher.
Higher. Hambali?
Lower.
Okay, Hambali kata lower. Najwa?
Higher.
Kenapa lower, Azam?
Higher.
Apa?
Kenapa higher?
Kenapa high? Kenapa awak kata higher ke lower? So base resistance is lowly doped. So the resistance is higher or lower?
My
Azam?
answer is lower
So why lower?
because there are less free electron. Free.
So when it's less free electron, is it high or low resistance? Ni bukan conductance lah, ni resistance. Okay, the answer is the higher the doping, the lower the resistance. Okay, because you have more free carriers for it to that can flow. So it means that in this area here, is low doped. When it's low doped, it means that the resistance is higher. So which is a problem. we want to the reason why we low dope because we want to reduce the amount of recombination, which is good. However, there ada side effects. So dalam hidup ni everything have side effects. Makan ubat ada side effect, Samicon pun ada side effect. So kita pun apa-apa kita buat ni kena ada implication and side effect. So what happens is because of that, not only because it's low doped, it introduces resistance, higher resistance in the material in that region. So therefore, kalau saya nak draw. Kita draw apa lah. So setiap ni ada resistance. Okay, can you see my resistor? Okay, so what happens is the current has to go through here, go there. So if you can imagine the current that going to the first diode, so let's say 1, 2, 3, 4, 5. The current that goes to the first diode has to go only one resistance, has to go through only one resistance. But diode number 2, it has to go to two resistance. So this is R. So R, so this is 2R. So now the third one, it has to go to 3R, 4R. So can you imagine, by the time the current goes to the fifth diode over here, is there a lot of current or no? Here. In diode number 5. The current that flows here, is it high or low? Low, because it has to go to a lot of resistance, so low. So most of the current will go where?
One.
See, so most of the current will go to 1. So can you imagine? Okay. So you need to, another thing that you need to imagine here is the apa nama tu? Dia punya spot. So this region here. So can you imagine in a small area, you have a lot of current flowing compared to a bigger area, the same amount of current flowing. Is there any difference? Saya lukis dah, tu tak nampak. So macam this card ni dengan ni. So yang ni 1 milliamp flow through. This is 1 milliamp flow through it. Wire ni kan. Ada difference tak?
The resistance?
Not only on the resistance, about the the current density. So which one have a bigger current density, A or B?
A.
Huh? Which one has a bigger current density, A or B? Hambali?
A.
Huh?
A.
Hamli kata A, Najwa? Macam mana ni, kita tak ada apa, mutawatir. Hadis yang mutawatir ni semua agree. So ada kat A, B. Salihin, A ke B? Have
A. A.
Tak dengar?
A.
Okay. A has a higher current density. Solihin kata, Azam?
B.
Azam kata B. Faiz?
A. Alpha.
Okay, semua orang salah tanya kan? The answer is, the answer is A. Why? Current density awak ni pun masa SPM tak ingat lah. Ke J, current density equals to current divided by area. So normally density we talk about volume, right? Kalau benda lain kita density divide by the volume. Tapi untuk current, when we say current density is actually current divided by area. So this is the smallest area. Therefore, this has the highest, the biggest current density. So So the problem is with this, when a lot of current flowing through this in a small area, instead of, because this current should spread, should spread equally. That's what we want. Sebab emitter ni dia tak kisah pun, dia just want when it comes out from here, the current, it doesn't matter, dia tak kisah pun sebenarnya kalau kita theoretically, tapi in physically what happens is most of the current will flow here and least of the current will flow here. What happens is this area here, we have the highest current density. So what problem will arise? The problem that will arise is current crowding. Okay. Another name of base resistance effect, nama lain dia ialah current crowding effect. Kalau awak baca buku, kalau kata awak rajin lah, bagus, so nanti student yang solehah, awak pergi baca buku, awak pinjam buku dekat library, and mungkin awak tak jumpa base resistance, mungkin nama lain yang dia orang pakai ialah current crowding. Kadang-kadang buku is the same thing, base resistance effect, current crowding effect. Kalau nak Google, is the same thing. Okay, so kenapa? What happens is bila saya kata tadi kan, most of the current will flow through yang diode number 1 tu, so the current density will be high. So this effect where all the current going through a specific small area, we call it current crowding, which is parameter of the emitter increase with bias. Sebabnya the problem is, okay, tu satu. Let's go back. So now you understand kenapa kita ada current crowding tu. Now you understand, right, why we have current crowding, because of over here their resistance, most of the current will go there. Now the next question is, if you look at this graph here, can you see this graph? As you increase the bias, as you increase the VBE, this deviation from the ideal is worse. So meaning the current crowding is worse as you increase the voltage. Betul kan? This is how, as a scientist or researcher, we are very you need to be very meticulous. So kalau setengah orang ni tak kisah je, nampak okay, this is like a reduction from the mean. Not only that, a scientist will also look at, not only that, as you increase the voltage, the deviation become bigger. So it's telling you something. So what is it telling you? Okay, to answer this, let's go back to the drawing. Okay, to answer this, so how come as you increase the bias, the current crowding become worse? Can anybody explain why, as you increase the voltage, this current crowding or the base resistance effects become worse? Anybody?
Current increase.
Apa?
Current increase.
Current increase kat mana? Where, how, what? Siapa jawab tadi?
Ya.
Aiman, sila jawab Aiman. So, can you explain more? Ni awak boleh guna ilmu 3 tahun awak belajar as a ECE student.
Is it the IP increase, madam?
The what?
IP current.
IP?
The IB.
No. We make
Related,
the Now we are supplying a constant current over here. So now we increase. So no, sorry. Okay, betul. Kita increase VBE. It means that the IB will also increase. So what? So kenapa? So why do we see this increase in current crowding and base resistance effect? Kau pernah tengok graf, rasanya benda-benda ni kau pernah belajar macam first year lah. You belajar about kecoh apa benda, R tu. You belajar dah ni masa first year. Ni just electric circuit punya soalan. Tapi in real application. Kalau tak, kita semua ambil electric circuit balik lah. Sadis. Siapa dapat apa nama A electric circuit, ada ke? Sini dapat A electric circuit. Tak ingat lah, ke tak nak mengaku. Sebab kalau jawab saya dapat A dan saya akan tanya siapa lecturer awak, mari kita buat balik. Revision dengan cikgu awak. Just kidding. Anybody?
Let's go to the other channel. Let's go to 2 or 3.
So how? Tell me how. So sila elaborate. Awak macam ada, saya tak faham apa nak cakap. Hari ni tak ada siapa tu. Who's the other student yang perempuan tu? Forgot the name.
Nah.
Aina. Aina nama dia. So mana Aina? Najwa, awak tahu? Sihat ke? Oh, bukan kawan dia ke?
Bukan dia semalam mungkin ni kot ada hal untuk kan sebab isolation kot, mungkin ada hal untuk isolation tu.
Oh, okay. So, the answer is because of, saya bagi keluar. Okay, saya bagi clue. Awak boleh sambung tak? Saya rasa saya tak nak jawab. I let you suffer. Okay, I want you to think of the answer. Bukan sebab awak tak boleh jawab. Awak semua patut boleh jawab benda ni. Sebab awak dah belajar. Kalau tidak, apa guna awak belajar 3 tahun tak boleh nak jawab simple question like this. Kadang-kadang soalan macam benda-benda macam gini akan come up in your real life hidup awak. So bukan real life, macam if you work in semiconductor factory. So you will answer this next class. Okay, brothers and sisters, get ready. It's okay lah, awak boleh Google. Tapi yang pentingnya awak kena explain sampai saya faham. And kawan-kawan awak faham kenapa as you increase the the voltage VBE, you have more of this this base resistance and current crowding effect. And then while you are doing at that, I want you to go and find out about this. So tu problem dia. Base resistance ni is a problem, tapi dia orang jumpa dah solution dia. Solution dia ni. Kena buat large interdigitated comb-like base and emitter contact. Saya tak ada gambar kat sini. I want you to go find the photo of this. So there's a solution for this. So as an engineer, why we need to know and understand all these problems? Because when we understand, we can offer solution. Itulah engineer, kita kena faham. Kalau tak faham, macam mana you nak solve? So every single thing, if you have to understand the physics, you understand the physics as an engineer, because we need to solve it. So solve the problem. So anything problem, the bottom line, we need to understand why is it happening. Once we understand why is it happening, then when we can offer solution. Okay, alright. Okay, I think that's enough for today. Okay, can we have somebody to recite the doa to end the class? Kita punya quiz apa? Saya janji itu. Solar cell dengan
LED.
LED. Okay. Solar cell LED. Better write down. Forgot. Okay. Doa. So for the quiz, please expect to be able to draw the energy band diagram. Okay, kalau tak boleh tu you will already fail the quiz. So saya beritahu dah jawapan mana dia, hak tu mesti ada. Tapi saya ada soalan lain jugalah yang akan mungkin mengejutkan anda. Tapi hak tu yang tak mengejutkan. So at least you dapatlah pass. Okay. So doa.
Bismillahirrahmanirrahim. Allahumma ahyina bil iman wa amisna bil iman wa hasyurna bil iman wa adkhilna jannata ma'al iman. Allahumma innaka afun karim tuhibbul afwa fa'fu anna wa amwalikina wal jami'al muslimina wal muslimat al ahya'i minhum wal amwat bi rahmatika ya arhamar rahimin. Rabbana atina fid dunya hasanah wa fil akhirati hasanah wa qina azaban nar. Wa sallallahu ala sayyidina Muhammad wa ala alihi wa sahbihi wa barik wasallam walhamdulillahi rabbil alamin.
Alhamdulillahirrahmanirrahim. So jangan lupa untuk puasa sunat 6 hari Syawal. Dah puasa ke? Siapa dah raya sini? Ada? Saya nak tampil.
Raya dah.
Ha?
Raya dah, Madam.
Awak dah habis nak puasa 6?
Tak, Madam tanya siapa dah raya tadi.
Sabar je lah. Raya 6 lah. So, ada siapa dah raya? Tak ada. Siapa dah puasa berapa hari dah? Anybody has started fasting? Sudah you yang Budiman, Aiman?
Hari ni hari kedua.
Okay, tahniah hari kedua. Orang lain?
Just start today.
Oh, start today. Okay, saya pun baru start hari ni. Tapi saya ada alasan. Awak tak ada alasan, Azam. Okay. So, orang lain yang tak start tu pun alasan anda. Okay. So, silalah puasa 6. It's good for you. Banyak pahala. Apa pahala dia? Ni, pahala puasa 6?
Sebenarnya puasa setahun nak saya.
Jangan kata tak silap. Nanti saya pun tak ingat. Saya takut terkelukar dengan hari Arafah. So macam we need to always be sure. As an engineer, sure in whatever you say. In Islamic pun kena sure. So that's how I've been trained. Kalau dengan supervisor saya dulu kena tembak lah kalau cakap benda-benda yang tak sure. So I always been trained like that. So nanti boleh share dalam Telegram hadis tu. So silalah kita bersama-sama puasa 6. So kita ada lagi banyak hari ni. It's good for you and then good for akhirat kita insyaAllah.
So siapa yang berpuasa Ramadan kemudian dia mengiringinya dengan 6 hari dari bulan Syawal, maka seperti ia berpuasa sepanjang tahun. Hadis riwayat Muslim.
So imagine macam puasa setahun dia tambah 6 hari je. Takkanlah tak nak buat kan, Najwa? Kita buat tak? Laki-laki lagi lah tak ada alasan langsung untuk tidak buat. So semua kena buat lah. Okay. Alright, let's end with tasbih kifarah and surah Al-Asr. Subhanakallahumma wa bihamdika nashhadu an la ilaha illa anta nastaghfiruka wa natubu ilaik. Bismillahirrahmanirrahim. Wal 'asr. Innal insana lafi khusr illa alladhina amanu wa 'amilus solihat wa tawasaw bil haqq wa tawasaw bis sabr. Assalamualaikum warahmatullahi wabarakatuh.
Ada password.
Oh, password. Okay, password for attendance today is puasa 6. Jadi ingat sikit lah kalau tulis tu. Hopefully. Okay. Alright.
Thank you very much, Madam.
Okay, no problem. Bye.